Welcome back, guys. This is the last tutorial of this chapter, and in this video, we are going to learn about LCM. LCM stands for lowest common multiple. We already know about common multiple, and LCM is common multiple. Among the common multiple, the lowest one will be the lowest, LCM. It will be very easy, but let's first read the definition once. The lowest common multiple of two or more given number is the lowest or smallest or least of their common multiple. It's simple English. We'll understand this by an example, okay? Say I want to find the LCM of LCM of 4 and 9. Okay. First, what I need to do is find the common multiple of 4 and 9. So if I write down the multiples of, you already know this method, common multiple, how to do it. I'll do it again here. First I need to write down the multiple of 4, that is 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, 44, 48, 52, 56, 60, 64, 68, 72, and so on, right? And the multiple of 9 will be 9, 18, 27, 36, 55, 54, 63, 72, and so on. So we have wrote down the multiple of 4 and 9, but we need to find the common multiple. So if you search, you'll find out that 36 is a common multiple, 72 is a common multiple, and since it goes to infinity, there will be more common multiples, okay? But just let's take it 2 for now, okay? So common multiple of 4 and 9 is R36, 72, and so on to infinity. Okay, but it's asking about, we have to find LCM. So the LCM will actually be 36. These are the common multiple, okay? But since it is the lowest, therefore it's a LCM. The name itself suggests lowest common multiple. This is the common multiple and this is the lowest, so this one will be the LCM, lowest common multiple. So LCM of 4 and 9 is 36, right? And if I read the definition again, the lowest common multiple of two or more given numbers, say this LCM of 4 and 9 is the lowest of their common multiple. So of their common multiple, this is the lowest. So like HCF, we don't need to do this method to find out the LCM. There's another method. There's a better method indeed. I'll teach you how to. What I need to do, it's similar. I mean, the working is it's similar to prime factorization method, but it's not actually prime factorization method. So I need to find the LCM of 4 and 9, right? 4 and 9. I need to write it down here. And alright, let's take the first smallest number, 2. Is any number among them, not both, is any one of them is divisible by 2? Because we have taken the first number 2. I have not written it down because we don't know that it's whether any number will be divisible by 2 or not. But we know that 4 is divisible by 2, so I'll write down the 2 here. So 2 and 9 as it is. Again, is there any number divisible by the same number too? Yeah, there is. So 9. Next number will be 3. Next prime number will be 3. So this 9 is divisible by 3, so I'll just write it down. 3. And again 3. So LCM is 2 into 2 into 3 into 3. 2 into 2 into 3 into 3. That is 4, 9. 9 4 is 36. It's the same as this one, right? You either do this way or this way, but this one is better. It is, I know that you need to practice it to like sink in. So I'll do another one for you guys. So I'll do LCM of 20, 25, and say 30. It's in the example. I'll just do it in front of you. So what I need to do is I'll write it down: 20, 25, and 30. We know the drill. First, we need to write the smallest prime number, that is 2. Is any number divisible by 2? Yeah, 30 and 20 is divisible by 2, so I'll write it down. Then 25 will stay, it's not divisible, so I'll write it as it is. 15. Should I write down 2 again? Yeah, because there's 10. There's still a number which is divisible by 2. So I'll write it down here. 2, 5, 25, and 15. Now, I can write down 2 here because no number is divisible by 2, right? The next prime number is 3. And we know that 15 is divisible by 3, so I need to write it down here. Other numbers will stay at it as it is, 5. And now it's not any number is not divisible by 3. Next prime number is 5, and I wrote it down because you already see 5 is there. 5, so 5, sorry, this one 1, sorry about this, and last one 5, right? So LCM of 20, 25, and 30 is 2 into 2 into 3 into 5 into 5. This one 2 into 2 into 3, 5 into 5. And that is 10, 10. That is 100, 300. So LCM of this number is 300. What it basically means is 300 is the number which is divisible by 20, and which is divisible by 25, which is divisible by 30, and there are more numbers which are divisible by 20, 25. Okay, x, y, z are also there, but 300 is the number which is divisible by all of them, and it's the smallest number which is divisible by all of them. Other numbers will be greater than 300. They, like x, is also divisible by all of them, but it's not the smallest number which is divisible by these three numbers. 300 is the smallest number which is divisible by all of them, so this will be the LCM. LCM means basically this, right? There's an interesting question coming up. I'll write it down first. We have to find the least number which, when divided by 12, 16, 24, and 36, leaves a remainder 7 in each case. My handwriting is a little bit bad, but I'll read the question for you. We have to find a least number. Least number is we have to find the LCM, okay, which when divided by 12, 16, 24 and 36 leaves a remainder 7 in each case. So what it is saying is there is a number x, okay, which is divisible by 12. Which when divided by 12, which when divided by 12 it leaves a remainder 7. Remainder, okay. And this same number x when divided by 16, it also leaves remainder 7. Similarly, if the number is divided by 24, the x number is divided by 24, it leaves a remainder 7. And 36 also, if we divide this x by 36, it leaves a remainder 7. That is the question. We need to find the x. Like, what is the number which when divided by 12, 16, 24 and 36 leaves a remainder 7? So what we need to do is, it's simple. We'll find out a number, say the LCM. We'll find out the LCM, okay? First LCM. We know that LCM is the number which is divisible, means there's no remainder, which is divisible by all of them, 12, 16, 24 and 36. So this LCM is divisible by, because this is the LCM of 12, 16, 24 and 36. Since it is the LCM of 12, 16, 24 and 36, it is divisible by all of them, right? When 12 or 16 or 24 or 36 divide this LCM, there is no remainder. And LCM, we have already studied, it is the lowest common factor, means it is the lowest number which is divisible by all of them. The four numbers 12, 16, 24 and 36, right? So we'll first find out the LCM, right? So we found out the LCM, then we just need to add 7 to it. That's the answer. Let's just do it for better understanding. So the number, so first we need to find out LCM of 12, 16, 24 and 36, right? So wait for so we need to find the LCM of these, and we know the method. We write down 12, 16, 24, 36. First 2, 6, 8, 12, 18, again 2, 3, 4, 6, 9, again 2, 3, 2, 3, 9, once more 2, 3, 1, 3, 9, and next one will be 3, 1, 1, 1, 3, and last 3. So LCM of 12, 16, 29 and 36 will be 2 into 2 into 2 into 2 into 3 into 3. 2 into 2 into 2, 4, 4, 4 is 16, 16, 9, yeah, right? That is 160 minus 16, 144. So this 144 number is divisible by 12, 16, 24 and 36. When they divided, any of them divided, there's no remainder. Alright, there's no remainder, and since it is LCM, it's the smallest number divisible by them, all of them, and there's no remainder. If I add, the answer will be, if I add 7 to the LCM, that is how much? 151. So this number, when divided by any one of them, it will leave a remainder 7, right? That is the answer. Thank you guys for watching. It was my last tutorial for this chapter. I hope you see other playlists too. Thank you guys.